Hi everyone. So now let me start basically. So I think we have discussed two topics so far, like what is Palo Alto, what is like firewall, this definition we have understand, and I have also gone through some concepts like what is inbound traffic, what is outbound traffic, what is ingress traffic, what is ingress interface, what is inside, outside, DMZ zones and all right. Now see what firewall basically used to do. The traffic which is good, basically it used to allow that good traffic, and the traffic which is bad for your organization, it used to block that traffic. So like firewall, you can think like a security guard in your society or in your office environment, right? What is the duty of those security guards? What they used to do? They only allow the legitimate peoples, right? The peoples who have the access of that particular office, they will allow only those peoples, right? They check the ID card and all, right? If you are not having any ID card, then they need some kind of email from your manager and all, and after that only you will get the access. Okay, so firewall is also like a similar thing. It is like a security guard. We have couple of vendors of the firewalls. Let me just tell you some of the vendors. So the first vendor is your Palo Alto firewall. We have a firewall from FortiGate. The second vendor or second OEM for firewall is your FortiGate. Then we have a checkpoint firewall. In Cisco F2 firewall, Cisco ASA, and Cisco FTD. Cisco ASA and Cisco FTD. Then we have a firewall from Juniper, which is Juniper SRX. We have a firewall from SonicWall, WatchGuard, StoneSoft, right? We have a firewall like CyberRoom. Those are the couple of vendors, and just remember few names. That is only needed. Okay. Now, before going into stateful inspection, just wanted to give you some idea about what is NGFW, what is next generation firewalls, and what is legacy firewalls. Those we have to understand. Okay. So let me do some cleanup here. Okay. Now, the legacy firewall or the next generation firewall. So we have to understand the main difference between legacy firewall and the next generation firewall. And nowadays, most of the organization, they are basically using the next generation firewalls. Okay. So in the list of next generation firewalls, so we have a firewall from Palo Alto Networks, which is Palo Alto Firewall is a next generation firewall. FortiGate is a next generation firewall. Checkpoint is a next generation firewall, and Cisco FTD is a next generation firewall. So those are the popular and well-known vendors. Those are the popular and well-known OEM, I can say. Well-known OEMs who has the next generation capabilities in their firewalls. In the list of legacy firewalls, I kept like Juniper SRX, Cisco ASA. These two I have put on the top because from the legacy list, those firewalls is also very much popular, and most of the organization they have those two firewalls, Juniper SRX and Cisco ASA. Okay, and the third one is SonicWall, CyberRoom, Barracuda, WatchGuard, StoneSoft, firewall from HP, Dell, IBM. Okay, so couple of other firewalls are there, and those firewalls are comes under the legacy firewalls. The main difference between next generation firewalls and legacy firewall is that your next generation firewall can able to control the traffic. What do you mean by the control? Means they can able to allow and they can able to deny the traffic on the basis of your layer 3 information, your layer 4 information, and your layer 7 information. From layer 3, most of the time they will consider 3 fields: source IP, destination IP, and layer 3 protocol number. From the layer 4 field, source port, destination port, and from this layer 7, they can also able to read the data. They will read the layer 7 data, or they will read the payload. They read that payload, and what they will do, they will analyze that payload, and what they will offer two features. One feature is application identification, and the second one is content identification. Because your next generation firewall is capable of reading, capable of processing the layer 7 data from the packet, and because of that layer 7 data, they offer two additional feature. First one is your app ID, and second one is your content ID. Because these two features is supported by the next generation firewalls, so they gives you the app identification. Virus protection, because they are reading your payload, which comes under the content. Virus protection, spyware protection, vulnerability protection, it comes under the content ID. So virus protection, spyware protection, and vulnerability protection is also known as a IPS, intrusion prevention system, which means these devices or these next generation firewalls, they will give you the IPS functionality. They can able to read the layer 7 payload, which means they can able to read the HTTP header properly. So this supports the URL filtering as well, data filtering, your file blocking, sandboxing, DNS sinkholing, and the user ID. Those are the extra features which is supported by those next generation firewalls. Now, come to the legacy firewalls. Legacy firewalls can only able to perform, can only able to understand layer 3 information and layer 4 information, which means we can only able to write the security rules on the basis of source IP, destination IP, and layer 3 protocol number. And layer 4, they will use the source port and destination port. Those legacy firewalls, they cannot able to support, they cannot able to read layer 7 data. Layer 7 information they cannot able to read. So they will not offer features like app identification, features like content identification. That is the main difference. That is the main difference between next generation firewalls and the legacy firewalls. Now, see, these 4 firewalls, they have a very nice and very huge database for app identification and content identification. But those vendors, see, because those vendors, they also want to run their business, right? If they want to run their business, then they also needs to implement those app identification and content identity. So those features, they are slowly adding, but still those devices, they comes under the legacy list only because their database is very less. People do not wants to use the layer 7 functionality from those devices. I'm talking about the enterprise customers. Okay, when I'm telling anything, I always take a reference from the enterprise customers, not the small organization and all, because in a small organization people can do anything. Okay, but in a large organization, in the enterprise customers, they don't want to use those layers and functionality into those devices because they are not much capable. You will face lots of challenges over there. Even though, let me tell you one true story, guys. Why Cisco market is down? Cisco was the market leader, right? If I'll talk about the 2010, 2012, or like 2015. Till 2015, Cisco ASA was the most used device in the organizations. 8 billion people's, 8 billion firewalls was the ASA firewall was there in 2015. Why? And even though ASA is a legacy file, because it has a huge popularity. This device is very good. ESA is a very good firewall, I can say, if you only want the feature or inspection at layer 3 and layer 4, plus you just need a VPN. If you just need these two functionalities, I always recommend you can go for ASA. Always it is recommended, go for ASA. Now, because Cisco has understood the market, because Palo Alto was there in the market, FortiGate was there in the market, they are just killing the Cisco business. So Cisco has designed one product called FTD. But FTD is not gain the much popularity in the market. Why? Because it has lots of issues. Similar thing you will face with those devices. If you will use the layers and functionality on those devices, they will not give you the appropriate results. Even though your checkpoint is also struggling nowadays. In most of the organization, you will see only two firewalls, Palo Alto and FortiGate. Huge market cap. Palo Alto is the #1 firewall according to the Gartner report, and after that we have FortiGate. So all the customers who has a nice, I can say, budget for their IT, then they used to go with the Palo Alto. And the customers who is not having good budget, then they use implement FortiGate, because FortiGate devices are little bit cheap in comparison to the Palo Alto. But both will give you the same type of functionality. There is a some here and there, always you will see. Okay, now, because guys, those next generation firewalls, they support they can able to understand layer 3, layer 4, and layer 7, right? Because they are reading layers, and which means they offer one feature, very nice feature, app ID. What do you mean by the app ID? App ID is a application identification. Means, let's suppose, let me give you one very good example of Facebook. We have a Facebook application. We have a Facebook app. Now tell me one thing, in Facebook, it has lots of child application. We have a main Facebook, main source code of Facebook is known as Facebook base application. In Facebook, you can see you can able to do the chatting as well, right? So we have a Facebook chat application. In Facebook, you can able to upload the photos, and also we have a Facebook uploading. In Facebook, you can able to do the audio and video call, right? So we have a audio application, Facebook video application, Facebook games, multiple applications are there. Because of this feature called app ID, now what you can able to do? Now you are not only restricted. See, if you have a legacy devices, Tell me one thing, guys. If you have a legacy devices and you want to block the Facebook, let's suppose you want to block the Facebook application. Now, how you will block the Facebook application using legacy firewalls? How you will block the Facebook application of Facebook traffic using legacy firewalls? What options we have? Write on the chat, guys, what options we have. Ankit, Amit, what options we are having here? IP and ports only? Ankit and Kamlesh, I'm talking about the legacy firewall. There is no app ID. There is no app ID. There is no URL filtering. Okay. So only the options which are available is layer 3 information and layer 4 information. At layer 3, we have a IP address, and at layer 4, we have a port numbers. Now guys, see, you have now, let's suppose you have requested to Facebook, they have provided the 1000 IP address of their servers. You have added those 1000 IP address in your access list. Let's say we are using ASA. So you have created the access list and those 1000 IP address. And let's suppose 200 port numbers you have received. So those 200 port numbers you have added in your ACLs. Now, and let's suppose across the globe, you have 2000 firewalls. Across the globe, you are an enterprise customer, you have a 2000 plus firewalls. Now let's suppose one day Facebook has implemented couple of new servers. Couple of new servers is added. Let's suppose now there is 100 new IPs they have configured on those servers. And let's suppose they have added around 50 more port numbers. Now, do you think when Facebook will do those changes, when Facebook will do those changes, do you think they will inform you? They never inform you, right? Who are you, right? For them, right? They say, who are you? Why we should inform you? Now, for those 100 IP and 100 port numbers, now there is a traffic which is allowed. That traffic is start going through those particular for those particular IPs and port numbers through your firewall, which means whatever policy you have configured, that is useless now, right? It will not serve the purpose, which means now you have to basically, if you want to, now those changes are there. If you will add those IP address again into those network objects or the service object, then your policy start working. But do you think I'm talking only the Facebook application. We have a hell lot of number applications. Hell lot of numbers of applications out there nowadays. Right? Do you think those exercise we can able to do? It is a good solution here. Is there any type of scalability? Like after every week, you are not going to perform those changes in 2000 firewalls. Right? Even though if you want to add a single line of ACL in your 2000 firewalls, you need a manpower. Right? You need a 5-6 engineers, and if they will work continuously till 1 week, then only they can able to implement that particular change. And which is not scalable, right? It's not a good solution at all. Okay, that was the problem people were facing with those particular devices. Right? And you know, guys, when Palo Alto came in the market in 2005, this device comes up with the next generation capabilities. This firewall have a built-in those next generation firewall capabilities. App ID was the feature which is first time introduced by the Palo Alto networks. And it has solved lots of problems people were facing. Let's take an example of torrent or Yahoo. Those are the evasive kind of applications. What they used to do, torrent IP address and port numbers is not fixed. And they never share those details with you. If you will ask, because those are the pirated, right? Those are the malicious websites. Why they will send those details with you? You have to figure it out. So, you know, to block the traffic for such type of evasive application was the major challenge which is faced by the peoples during that type particular time. Because you know those applications, they can run on DNS. Your DNS works on UDP port number 53. Torrent and Yahoo can run on port number 53. They can run on port number 443. They can run on port number 22. Then how you will restrict those particular application? Through your legacy firewalls. There is no way, right? Because see, those particular servers, they are opened for all type of port numbers. You can send the request on any port. They are open for that. Okay. So those type of traffic, we are not able to control using this legacy firewall. And also one more challenge. If I'll take example of Facebook, if you will block those 100,000 IP address of Facebook, which means you have completely blocked the entire Facebook. Now there is no communication with the Facebook. But with those next generation firewall, what you can able to, let's suppose you want to restrict the chat, you want to restrict the uploading, you want to restrict the audio call, video call, gaming, those things you can restrict. Normal Facebook will work. Maybe chat will not work. People not able to do the Facebook chat. People not able to do the video call on the Facebook, audio call on the Facebook. Those type of or that type of control you will get with the feature called app ID in the next generation firewalls. Okay. So that is the some basic idea of this app ID. So this was the feature which is available in your NGFW firewalls, but that feature is not available in the legacy firewalls. So that is the also one more reason your next generation firewalls is very much popular nowadays in the network. Now, let's try to understand the second thing. Or I will combine because I have a separate discussions for those topics. Okay, but see those three features. Those three features. Don't worry, Marcus. I will cover those things. Okay, don't worry. App ID, we have a separate class for app ID where I will tell you how app identification happens for TCP, for UDP, what type of database it utilized. Okay, how we can create our custom application. All those practicals are there. Okay, but here just understand we can able to now control the traffic not only on the basis of our layer 3 and layer 4 information. Now we can also control the traffic on the basis of application. We are utilizing now layer 7 information. Previously, if we want to allow something or we want to deny something, we have only the option of source IP, source port, destination IP, destination port. But now we have an option of application. We can allow DNS traffic. We can allow SMTP traffic, SHS traffic. Now there is no need to define those IPs and port numbers. Those are optional. We can define those application only. We can allow Facebook. Like I guess I have some of the rule. Let me just show you that as well. Not 100% sure I have anything at the on the base application here. Yes. Oh. See if you will see this rule here, this one, see this one. This rule I have created on the basis of applications here. And that those database are available here. Those are the application which we can use. We will do lots of practicals. Like those are the application which I have created. Those are the custom one which I have created. How we can create custom application, everything we will discuss. No, app ID is not on the basis of IPs, not on the basis of INI and all. Okay. We have a altogether a separate database for app identification and all. We have a separate signatures for that, which is managed by the vendors. Like for Palo Alto, it is the database which it utilized, which is known as Applipedia. And that database is available for the well-known applications. Not we don't have a application for all apps, but all the well-known applications out are available. Okay, now those three features basically, if you want virus protection, spyware protection, and vulnerability protection. If you want to utilize those three features in NGFW, next generation firewall, then those features are built in. Those are built in with the same box. But with those legacy firewall, what device you have to use? You have to deploy one IPS device. You have to purchase an IPS solution and you have to deploy a totally new hardware box. You have to deploy totally new hardware box. Okay. So, but in Nexus firewall, you will get those features just in single box. So now you don't need any extra hardware. You not need to manage the life cycle of that hardware box. You not need to hire any engineer who can manage your IPS box. That is the one benefit. Why those particular devices, those legacy firewalls, they are not able to do those IPS functionality? Because those devices is not able to read layer 7. Layer 7 information they are not able to read, but your next generation firewall can able to read the layer 7 information. Now let me tell you one more thing. See, tell me one thing. See, I have created one malware. I have created one malware, or let's say I have written some malicious virus code. And let's suppose that particular code is available on my server. And that server is running on FTP and on TCP/IP. Now when any client try to connect with this particular server, and when this client will try to download any of the files, and I have added that malware or that virus code inside the file, when he will try to download that file into his computer, into this client machine, now when he will download this particular malicious code or malware, how it will transfer that particular malware? It will transfer as a layer 7 data only, yes or no? This malicious code or virus code comes as a layer 7 payload only. Tell me one thing, are we able to add any payload into your layer 3 header? or the layer 4 header? Are we able to add any extra thing in the IP header or in your TCP header? We are not able to do that, which means those malicious data will come, or those malicious code will come as a layer 7 data only, right? At layer 7 in the format of data or in the format of payload, right? And you do you think those legacy firewall able to read this layer 7 information? No. If they are not able to read this information, then do you think they can able to process? They can able to protect? No, right? But my next generation firewall, they are able to read that particular layer 7 data. If they are able to read that data, which means they can able to protect us. Okay. If any virus is coming, they will offer you the virus protection, spyware protection, vulnerability protection. Okay. So those features is also there in your next generation firewalls. Now, one more thing. We have a URL filtering. See, how firewall, tell me one thing, guys. Let's suppose you have opened one website which is based on TCP port 80. Then where basically URL detail is available, right? In your HTTP request, in your HTTP request packet or in your HTTP get packet, from this get packet, they will get the URL detail. Yes or no? What is this HTTP is a application layer protocol, right? Which means it is also at layer 7 only, right? Which means your URL filtering is only available into those devices because they are reading layer 7 information. Okay. So those features like URL filtering, same with the file protection, DNS synchrolling or user ID, all those features available into those next generation devices only. Why? Because those devices, they are capable of reading your layers of information and they offers those features, but those features is not available into those devices, those legacy firewalls. So that is your next generation firewalls and the legacy firewalls, or next generation versus legacy firewall. So I can see one question. Sir, I am having all these features on the firewall, then why do I require antivirus or EDR or endpoint or servers? So it's a very nice question he has asked, like why we needed the EDR based solution or the endpoint based solution. So I know very good example for that. Let me tell you one thing. Let's suppose I have designed one malware. I'm capable, even though guys, I can able to create those malwares. And I think in future classes, I'll try to create some of the malwares. So, let's suppose I have created one malware or I have created one virus code. Okay. And that virus code, basically that code I have divided into 100 chunks. I've divided into 100 pieces. Okay. That particular code is divided into 100 pieces. And I have basically uploaded into one of the server. Okay. Now, when any user, any client machine start communicating with those servers, I will not send all the entire virus code just in single communication. I will send this particular code into multiple communications. In those cases, there is a high chance my firewall not able to read that particular virus because there is no full code. If that full code is not available, why? Because how this firewall is doing this, it uses some signature database. That time that signature database is not able to detect, because that database is not that much intelligent, so he can able to detect the small chunk of the virus code. Once all those 100 chunks will be downloaded into this client machine, what they will do, and after I did some type of programming, all those chunks will gather here and the virus code will be created, and the entire malicious code will be created, and it will run that code into this client machine. Then how I can protect? If I am not having any endpoint solution or the antivirus solution in my client machine, then how I can able to protect? There's no way, right? So that is the main reason we needed endpoint security solutions always in the client machines. This is the one thing. The second thing, we needed those particular endpoints and all for one more reason. See, I have a virus malicious code, and there is a technology, there is a some encoding is available. Let's suppose, see, my firewall can able to detect if I did the encoding till 4 layer. But let's suppose I did here 6 layer of encoding, and that encoded file I am sending through this firewall, then firewall will not able to detect. Then who will detect? Once this encoding, because now if we want to run this particular malicious code in this machine, then that encoding needs to be removed. When this encoding will be removed, when we will get the plain code here, then only endpoint security solution will detect. So we needed the endpoint security solution. There is a one more example. Sometimes people use sends the sleeping virus. Sleeping virus means that virus code is not looks like a malicious one. Once that particular code reads into the computer machine, that code will wait maybe for 6 months, and after 6 months it will activate. Then how you will block that particular malicious code, right? We need an endpoint security solution. And also one more thing, see, might be sometimes if some of the organization generally don't allow, but some of the organization they allow the USB cable, right? You can able to connect your USB drives, your hard drives and all, right? And some companies allow the internet access directly from your PC. And that time your traffic is not going through the firewall, right? If any type of malicious code is coming, then those codes will be detected by the antivirus solution or endpoint security solutions only. Okay. And also one more thing, guys. See, my firewall protect us when data is in motion, when data transfer is happening. But if data in rest, then who will protect? Those type of protection done by the endpoint security solutions only. What is signature? Those things I'll cover in the future classes case. Okay, not now, because it otherwise it will divert the entire discussion. Okay, now guys, let's try to understand the stateful inspection. Most important topic. I'll just discuss this stateful inspection today, and after that I'll just bind up for today. From tomorrow I will start the Palo Alto Firewall product portfolio and other stuff. Okay, and the history and all. Let me just tell you something. I will utilize those diagrams. So let me just do some cleanup here. 1 minute. So this is the one diagram. And second, I will utilize this one. Let me just do the cleanup here as well. Okay. Now, guys, let me tell you one thing. See, your routers is a stateless device, and your firewalls are the stateful devices. What do you mean by the stateful devices? My firewall used to maintain the state table. What? They used to maintain the state table. They have a record of entire communication which is happening between client and server. But your router are the stateless device. So let's try to understand how router is doing the packet processing. Let's suppose this router is trying to download one of the file from this particular server. Let's suppose that server running on TCP port 80 and the IP address is 151.100.100. And let's suppose there is a one file of 4 GB. There's a 4 GB file. It's a MP4 file. Okay. Let's suppose there is a one movie is reside on this server. That movie I want to download, and that particular server is running on port number 80. Then how router is going to do the packet processing here? I have my PC, which is the inside network. I have a router, then I have an internet outside, then I have internet service provider ISP, and after that I have a server somewhere in the internet. How this communication is happening? Let's try to understand that. And this is a stateless behavior. Your router is a stateless device. Now, guys, tell me one thing. In this communication, what is the first packet? I can say like this. I think this will not help us. Okay, so let's try to do like this. See, what is the first packet here? TCP send packet? Yes or no? Now, you know, guys, when this packet is initiated by this PC and when it reaches to this router on this Ethernet 1x2 interface, and let's suppose it's a Cisco router, for example, then this Cisco router will perform around 27 checks. This router will perform around 27 checks on this packet, and after that it will egress out this packet via the egress interface. So out of those 27 checks, I'm writing few of them. The first check, let's suppose it is doing, it will put this packet into the ingress stage. Okay. In ingress stage, it will do the packet processing. It will start processing the packet on the basis of layer 2 information, layer 3 information, layer 4 information, right? It will check if we have configured the access control list. ACL we can able to configure in the router. It will check the ACLs. Then it will check the, if we have configured the net, then it will check the net. If we have configured the policy based forwarding or PBR, policy based route, it will check the policy based routing. It will check the routing table, right? It will check the SEP table and the other checks. All those checks it will perform, and after that only it will basically do the packet forwarding. Then seventh one, let me just write down forwarding. Okay. This is how it will process this TCP SYN packet. Now, once this particular packet is processed by this router, this packet egress out by Ethernet 1x1 interface, it reach to the server. Now, once server receive this TCP SYN, he will reply with the second packet, which is TCP SYN plus ACK. Now, SYN plus ACK is also processed similarly. Ingress stage, then access control list, NAT, PVR, routing, SAF, and the forwarding stage. Means all total 27 checks it will perform here, and here also it will perform the all these 27 checks. Okay. After that, he will send the next packet. This packet is a TCP acknowledgement. TCP ACK also will go through with all those checks. Ingress stage, ACL, NAT, PBR, routing, SAF, forwarding. Means 27 checks it will perform on this packet as well. Okay. Now after those three packet, what is the next packet? Next packet this PC will initiate, which is a HTTP GET request, yes or no? HTTP GET also go through with all those 27 checks. You will get the HTTP response. Response also will go through with all the 27 checks. And after those two packets, what they will start downloading. So you will see lots of HTTP request and reply packets here, and all each and every packet will going through all those 27 checks. Okay. Let's suppose in this communication between this PC and this router, this PC and this server, let's suppose they has exchanged total of 200 packets. Total 200 requests and replies. In total, they have exchanged 200 packets. Okay. Now, let's suppose here in this communication, let's take an example. When my router is doing those 27 checks, let's suppose it is taking 2 seconds. for processing, for doing all those 27 checks. Here also 2 seconds. Here also 2 seconds. Here also 2 seconds. So total 2 seconds it is basically taking for processing each request and each reply. Then how many seconds this entire communication needed to download this particular 4 GB of file? 400 seconds, yes or no? So this is how my router is basically doing the processing. This is how my router is doing the processing. Now, guys, just try to understand here one thing. Now see, out of those, like when it is doing those 27 checks, the major checks is your ACL, NET, PVR, routing. Those are the 4 major checks. In router, what is the main function of router? Routing, right? We have a routing table. And if you have a millions of routes in a router, then definitely it will take some time. Which means those are the main functions: ACL, NET, PVR, and routing. And out of these 2 seconds, your ACL, NET, PVR, and routing, they needed 1 second. They needed 1 second. They just needed 1 second. Out of those 2 seconds, your NET process, ACL process, PVR process, and routing process, they needed 1 second. Okay. Now, if we can add something, tell me one thing, when this PC is communicating with this server, it is a same flow, yes or no? It's a similar flow for entire communication, right? It's just a single communication only. We are only creating one single session, right? With this server for downloading this entire file, so which means it's the same flow. Then do you think if my packet is allowed by the ACL, if my net rule is also fixed, PVR is also fixed, routing is also fixed, then do you think I need to repeat those tasks in each and every communication? Those, if I can add some technology, if I can add some technique which can bypass those 4 repeated checks, if we can bypass those 4 checks, if we can add some technology, and if we can bypass those particular 4 checks which is taking major time in your router, and if we can skip those 4 checks for subsequent packets, only in the first packet we can just send, we can check through those 4 checks, and for remaining packets, if we can skip for remaining packet, if we can skip those 4 checks, then tell me one thing, guys. Now for remaining packets, remaining 199 packets, how many seconds we needed? Only 1 second, because this process, these 4 process, they are taking 1 second. If we will bypass those 4 checks for subsequent request and replies packet, so out of 200 packets, out of 200 request and reply, only the first packet will go through all the checks which needs 2 seconds, and the remaining packet will need only 1 second. Yes or no? Guys, are you able to understand this? I'm skipping something. I have just skipped something. Some checks I have skipped because those are fixed. If my net rule is fixed for the first packet, then it is similar for second. It is similar for third. If my firewall ACL, access control list, is allowing the first packet, then it will allow the rest packet. Then why I should go for those repeated tasks? I can skip, right? And this is the idea behind your stateful inspection. This is the sorry, just give me 1 second. So guys, this is the idea behind the stateful inspection. In stateful inspection, I bypass the subsequent checks or the repeated checks for my upcoming request and reply packets for the same flow or for the same session. Same flow or the same session, which means for the same communication or this for same session, I will bypass. That is your stateful inspection. Stateful inspection. In a stateful inspection, we will bypass some repeated task. Okay. And very nice question is asked by the Ankit. What if we will create a ACL during the flow? So, you know, if you will create a ACL during this communication, then your ACL task will be evaluated again. If there is any commit happens or write command when you will run after any changes, your all your whatever the packets are there or whatever the sessions are there, all those sessions needs to be evaluated against the that particular change. It happens, it's a default behavior. Okay. Now guys, see, previously my firewall took around 400 seconds. Now if I'm bypassing those particular checks, which means for the same flow, how many seconds? 201 seconds, which is almost half. If it's almost half, which means what we have done, it will increase the firewall throughput by half. Yes or no? In comparison to the router, it will increase the throughput of the device by half. That is your stateful inspection. So in stateful inspection, firewall used to maintain the state table. It used to maintain the state table. Let me just tell you the some details. How state table it used to maintain, what information it store, everything I'll discuss, don't worry. So you know, in stateful inspection, what it used to do, your firewall device, it basically utilizes the layer 3 and layer 4 information within the IP packet and it stores the information in a separate table referred as the state table of the firewall. All the traffic or all the traffic flows through the firewall will be compared or inspected against the state table entries. It maintains the state of the connection when packet is traveling from the appliance. A stateful firewall maintains the state of the connection in the state table of the firewall. After adding information in the state table, it forwards the packet to the destination. When it receives the reply packet, it matches the packet information to the state table. If the firewall receives the reply packet, if match packet is accepted, then it will allow that packet or it will bypass the checks. Now let me just explain you this in terms of Palo Alto Firewall here. You will understand everything. Everything is possible, Praveen. Without checking the state table, how we can able to get the answer, right? Everything is possible. I'll show you. And I guess right now I have this firewall and I'll take the reference from here only. I only needed one connection. And I guess I do have multiple. The multiple connections are there, and mostly for the DNS traffic. Let me just pick one. Show session ID. This is the state table. This is the session, and if you will run this command like this, this is the state table right now on my firewall. Okay, so I'll take a reference from here. Oh, it is trying to communicate with my internal DNS server, which is right now down. So better. Just give me a second. Let me log in on this machine. I can generate some traffic. This is the. Don't worry, with the labs and everything I'll cover. This is the details I have. I think in this way only I have the communication. 1070 okay. Oh, this is the problem actually, because my external IP is changed. I have just changed my internet connection. I'm using nowadays Geo. Okay, so it should be 29.250. So I'm getting from 29. When we are, don't worry, all the communication. Okay, I'll do all those communications again. Okay. This is for global protection and the traffic. I can delete those portal and gateway. I don't want right now. Okay. I can do this here. Why I am just doing here and there. I have that server on DMZ, right? So we can check that session. I'll take a reference for that session only. Let me just see. Okay, I think it will fail at the validation level because it's a fully configured device. I have done some service route configuration and all. Use default. This also use default. Don't worry, I'll explain everything, okay? How this service route things works and all. But just wanted to show you something. I'm just changing those because setup is not right now according to that. I can delete this. Go here. One more thing, let me just do in my security rules. I can then drop all those not needed at all. Not needed this as well. Okay, those 3 rules I needed, and let me create one more rule. DMZ traffic. So I'll take the reference. That's it. Inside of DMZ, any source. Here also DMZ and inside. And let me just remove everything. Any application, any service, just allow. Let me do the command. Okay, now let's just go. Here, let's try to understand the. So guys, let me tell you one thing first. When you know, guys, let's suppose I have this PC here, PC1. I have my Palo Alto firewall here. And let's suppose I have a server here. Okay. Let us this interface Ethernet 1 by 2 and this is Ethernet 1 by 3. This is inside and this is DMZ. Here we have IP address 1070.1.80 and here I have a 1072.101. Very simple setup. Okay. Now guys, what used to happen? Let's suppose this PC is trying to communicate with this server. So it will send this packet. When this packet received by the firewall, so it's a TCP SYN packet, right? Let's suppose this server running the server on TCP port 22. So it's a TCP SYN packet. Now when my firewall received this packet, what it used to do, it used to process the packet according to the packet processing stages. So in your Palo Alto firewall, we have a 7 stages. We have a 7 stages. First stage is your ingress stage. Second one is your flow lookup, slow path, fast path, app ID, content ID, and the forwarding stage or the egress stage. So those are the 7 packet processing stages of your Palo Alto firewall. Okay. How those stages looks like? So if I'll go here, if you will see this diagram, in this diagram, basically when we receive the traffic, when we receive the traffic in your Palo Alto firewall, it will put this packet into the ingress stage. This is the first stage. Then flow lookup stage, the second stage. Then your slow path or session setup stage. Okay. Slow path, then it has a security processing stage or the fast path. Then app ID and after the content ID. And at the end, we have a forwarding stage. This is your forwarding stage. Those are the 7 packet processing stages, and your packet or your Palo Alto firewall or your Palo Alto operating system process the packets according to those stages. According to those stages. Now, let me tell you one thing. Your packet will go here. Your packet go for app identification and content ID identification if it has a layer 7 payload. or it has a layer 7 data, then only your packet will go inside the app ID and content ID. Okay. And in the entire communication, if I'll take a communication of that particular 4 GB file download example, then only your first packet will go through with this slow path. Out of those 200 packets, only your first packet will go through all those stages, and after out of those 200 only first packet will go through this slow path stage, and after that all the subsequent 199 packets, they will be bypass this stage. They will directly go into the ingress stage, flow lookup, fast path, app ID, content ID, and the forwarding. So you know guys, in stateful inspection, we are bypassing this session setup stage or the slow path stage. Okay, why we are bypassing? Because in your firewall, there is a technology called stateful inspection is implemented. Stateful inspection technique is implemented. Now let's try to understand this particular communication here. So, you know, guys, in this communication, if you will see here, see, my client is communicating with the server and he is trying to download the same 4 GB of file. So the first packet is the TCP SYN packet, right? Your TCP SYN packet processed according to this ingress stage, flow lookup, then slow path, then fast path, and the forwarding stage. Now, you can ask here one question. In this communication, why this app ID and content ID stage is not available? Why this stage is not there for TCP SYN packet? Guys, tell me the reason why app ID and content ID is not there. If you remember the TCP three-way handshake, what I have mentioned in TCP SYN, do we have any layer 7 data? Do we have any layer 7 data in the TCP SYN packet? Layer 7 data is 0. Layer 7 information is 0. In TCP SYN, SYN plus ACK, and the acknowledgement packet. If this information is 0, then your app ID and content ID will not come in a picture. Okay, because your layer 7 information is 0 in TCP SYN, SYN plus ACK, and the ACK packet. Now, when this TCP SYN packet is received by this firewall, once it will receive this packet here on Ethernet 1x2 interface, what it will do? It will start processing this particular packet according to the packet processing stages, according to the life of a packet. And at the first stage, it will put into the ingress stage. It will put this packet into the ingress stage. Once ingress stage will complete, it will move this and it will do the flow lookup. Now tell me one thing. What is this flow lookup? Now it is performing the lookup into the firewall session table. It will do the lookup into the firewall session table. Because in stateful inspection technique, the firewall device, it used to maintain the state table. In this state table, it will store the information of source IP, source port, destination IP, destination port, layer 3 protocol number, and source zone detail. Those are the 6 tuple or 6 tuple information it used to store into the session table with for a particular session. So now, in this case right now, in our case right now, when this packet is basically received by this firewall, it just processes at the ingress stage. Once this packet reaches the flow lookup, so guys, in this particular packet, in TCP SYN packet, let me write down some information. What is the source IP address here? Source IP address in this packet is 10.1.1.100. Destination IP address is 10.2.2.101. Source IP, destination IP address, then source port. Generally, source port is picked randomly by this PC. Let's suppose this time it has picked up 40,001. Destination port is 80. What is the layer 3 protocol number for this communication? Layer 3 protocol number is 6 for TCP and what is the source zone here? Inside, because this particular request we have received on Ethernet 1x2 interface, and that interface is a part of inside zone. Now this 6 tuple information I have received. I'm having this 6 tuple information. So guys, now in the flow lookup, so I have an existing session table. What using this particular 6 tuple? So let me write down those 6 tuple in a proper way here. Okay. Let me write down client to server. This particular communication is happening between client and server, from client towards the server. So I will write client to server. Source IP is 10.1.1.100. Destination IP address is 10.2.2.100. Sorry, 101. Source port 40,001. Destination port DP. It's a destination port. Okay. Destination port is 80. Layer 3 protocol number 6. And source zone is inside. I take those 6 tuples and my firewall run the MD5 hash on this, and it will get the hash value. It will get some hashed value. That hash value is known as flow key. Now I'm going little bit depth, okay? And I'm totally focusing on the Palo Alto. Now it will get this, and this key is known as flow key 1. Once I have this flow key, once my firewall have this flow key, and I am at this flow lookup only. I'm at this flow lookup only. Once I have this flow key, what I'll do now using this hashed value, I will perform the lookup into the session table. Now tell me one thing, guys. To store the information in a proper format in a device, what we need? To store the information in a proper format in a device, what we need? Database process. Without database, are you able to store any information into the servers? So you know in Palo Alto Firewall, the database it uses is the MongoDB. In MongoDB database, it used to store the session information in the flow key format only, the hashed format. Now, we have a flow key. Now using this flow key, I'll did the lookup into my MongoDB database or into my session table. Now tell me one thing. Did we get, do we get any type of session details here? Do we get any session details here? No. Why? Because it's a first packet, right? If it's a first packet, then how we will get that existing session, right? There is no existing session, right? Which means there is no session. If there is no session, now my packet move into the slow path. Now where my packet is going, now my packet is moved from flow lookup to the slow path. Why? Because according to the life of a packet, see here, firewall flow lookup match using the 6 tuple extracted at the English stage. If there is no match, it is going into the slow path. Yes or no? It is going into the slow path. And guys, as I have mentioned, I'm not explaining packet flow. When I will explain the packet flow, you will understand this in a proper way. KS, I think you are not focusing on the session. Okay. You are just going here and there. Why they are using MD5 hash? You can reach out to Palo Alto. They will tell you the answer, right? I'm not the one who can take that decision here. Now, once your packet reached into the silo path, if you will see the major checks, routing, net policy lookup, major checks I'm explaining here. In the security policy, those are the major ones I have told: routing, net, and your security policy lookup. Let's suppose I have a proper rule who is allowing that traffic. If my rule is allowing that traffic, rule allowed yes. Now it will do what it will do. Now it will create a session. Now it will create the session and it will install that session into the session table. If you will read this properly, let me just increase the size here. If rule is allowing, now what it is doing, he's creating the session and it will installing that session into the session table. Client to server and server to client flow also it is installing. See, now you can ask one thing. See here, I have the client to server information, this 6 tuple. How I will get the information of server to client? For the server to client flow, guys, what is the destination? What is the source IP? When this server give the reply, what is the source IP? So you know, in client to server flow, whatever the destination IP we are having, that destination IP become the source IP. Whatever the destination IP here we have in your client to server flow, in server to client flow, that become the destination IP, which is 10.1.1.100, right? Your source port is 80. Destination port is 40,001. See, information just swapped. Layer 3 protocol number will not change. 6. What is the source zone? How we will get this source zone? By the routing. Routing lookup we are doing in the silo path. What routing table used to tell? The egress interface. Once we have the egress interface detail, which is Ethernet 1/3 in our case, that's a part of DMZ, so we will get that source zone detail. Now you can see here, I have the client to server and server to client both flow, which means I can install those flow in the flow table easily. Easily I can able to install those flow, right? Now, see your packet will reach here and your session will be installed into the session table. What is the session life of a session? Don't worry. I'll discuss what is free, closing, close, opening, active, discard, everything we will discuss, but not now. I have a sessions for that, but here just understand my flow is installed into the table. Once session is installed, I'll go into the fast path. So I'm going into the fast path because in this SYN, I'm not having any layer 7 data. If there is no layer 7 data, which means I will skip the app ID and content ID. Those I will skip and I'll directly go into the forwarding stage. This is how the first packet is processed. And let's take an example. Let's suppose this first packet processing is taking around 2 seconds. I'm just going with the same flow. Okay. Now I am moving now into the second packet. So let me just do a little bit cleanup here. Okay. Now, what is the second packet? TCP SYN plus ACK. Now, TCP SYN plus ACK, when I have received this ACK packet into my firewall, what this firewall will do? It will process at the ingress stage. Completed ingress stage, it will move into the flow lookup. Tell me one thing, this time we have this particular flow key in the flow table, yes or no? Server to client flow we have already created. That flow key is already there in our flow table. That flow key is already there in the flow table. I will found, let's suppose the allocated session ID for this client to server and server to client is 100. Hypothetically, I'm taking because in your Palo Alto firewall, let me just go here. Let me go on my machine. Let me open the putty. Where is the putty application? Come on. 10.70.2.101 VMware. Let me create one flow VMware. I got the access of my DMZ server. And if I'll go and if I'll show you this, so session all, just look for this, show session ID. See, there is a one single session ID. It has a two flow, client to server and server to client. In this flow, if you will see here, according to our explanation, source IP is 1071.95, destination is 1072.101, protocol number is 6, source port is 3144, destination port is 20, type is flow, session state is active. Now, see, this source IP address become the destination IP address here. This destination IP address become the source IP address here. So they have swapped the information. Protocol number is fixed. Your source port 3144 become the destination port here. And your destination port 22 become the source port here. And they will, and your ingress interfaces they have, and also your see source zone is inside, destination zone is DMZ, right? Those are the six tuple. Those are the six tuple of your session table. Now this time, guys, when reply is coming, is this particular flow will match? This particular match will happen, which means it's a existing connection. If we have a existing connection, then according to packet flow, when they are doing the session lookup, if session details is available, yes, and state of the session is active. If session state is active, then they will directly move into the C opening or active, then they will go into the fast path, means your slow path is completely bypassed. Your slow path is completely bypassed now, even though we don't need to send the packet through slow path. That is your stateful inspection. That is your stateful inspection. Means in stateful inspection, my firewall maintain the state of the connection, maintain the state table for a particular connection or particular session or a particular flow. And if any upcoming request and reply packet are coming on the firewall, then it will match that particular session, and it for if match happens yes, then it will completely bypass the slow path. And that is the reason, guys, if you can see here, it just bypass the slow path. It just bypass the slow path. Ingress stage to flow lookup to fast path, and fast path to forwarding. Then the third packet, TCP acknowledgement is also processed. Ingress stage, then flow lookup, then slow path is bypass, fast path forwarding. And after that, we have a fourth packet, HTTP GET request, then HTTP response. And you know, guys, now see in your HTTP GET request, they have added extra app ID and content ID, right? App ID and content ID they have added because those packets they have a layer 7 data. But you can see here your slow path or firewall sets and setup state is completely bypassed for subsequent request and reply packets. Now, in the same flow, if they have exchanged 200 packets, and if your first packet TCP SYN 2 seconds and remaining packet just processed within 1 second, then 201 second will be taken by the firewall when it is doing the packet processing. So that is the main difference between your router and the firewall, because your router is a stateless device and your firewall is a stateful device. Firewall maintain the state of the connection. Your router, they do not maintain any state of the connection. They are the stateless devices. So I guess now, guys, you got the concept of stateful inspection. Very easy concept. In stateful inspection, firewall maintain the state table where it will store the 6 tuple information which are like source IP, source port, destination IP, destination port, layer 3 protocol number, and the source zone. For client to server flow, or same information will store for the server to client flow. And if any subsequent request and reply packet is coming for that flow, then the slow path will be bypassed and your packet will go for the fast pathing. Your packet processed at the fast path. Okay. That is your stateful inspection, guys, in your Palo Alto firewall. Very easy concept. See, if you will read this, it's difficult to understand. Even though I will not discuss that much information today, like those things I'll cover later. Okay. But it's the same thing. See, this is how they used to store the information into the session table. Now, let me tell you one thing. See, in the discussions, guys, if I'll say the term called flow table, or if I'll say the term called session table, if I'll say the state table, if I'll say the connection table, both are similar. I am referring the flow table only or the session table only, because most of the time I uses the term called flow table, not the state table or the connection table, because in actual it's a flow table. Okay, got it? It's the same thing. Do not confuse with this. If I'll say this, which means I'm talking about the state table or the session table. How it is storing? It is storing like this. MD5 hash information you will not able to see. You need a root access of this Palo Alto device, and after that only you can able to query into the MongoDB database. Now guys, coming to, let me just discuss few more things here actually. This technology called stateful inspection. This technology is implemented in 1993, and it is basically invented by the engineer called Nirjuk. Nirjuk was a engineer who has basically discovered this concept called stateful inspection while he was a part of Checkpoint. He was working for Checkpoint organization that time. Before Checkpoint, that same person Nirjuk, he has worked with the NetScreen. NetScreen nowadays known as Juniper. So initially he worked with NetScreen or Juniper, then Checkpoint. And in 1993, he have developed this technology. And this technology first time introduced by the Checkpoint in 1994 onwards. This technique is implemented in the other vendor firewalls like Cisco ASA. And you know, guys, it's a revolution. It's a revolution for the firewalls. Because of this technique, they have like while after implementing this technique into the firewall, it has changed the entire functionality of the firewall inspection. Okay, it has done lots of changes in the firewall packet inspection. Okay, the same person Nirzuk, he left Checkpoint basically, and in 2002 he has basically launched his own firewall, which is known as Palo Alto. So Palo Alto Networks firewall he has launched in 2002. In 2002, it was having lots of bug and because lots of bugs and other stuff on this firewall will not gain any much popularity. He have worked hard 3 more years, and in 2005, he has again launched the firewall with extra features. And in 2005, Palo Alto was the first firewall who supports NGFW functionality within the box. App ID kind of features, which was the unique during that time. And because of that unique features, this firewall gained huge market cap. And in 2008, but just within 3 years of a span, this firewall became the #1 firewall according to the Gartner reports, and it start leading the firewall industry. So till 2008, till now, Palo Alto Firewall is the #1 firewall, and he is leading this particular industry. Okay, so that is the some little bit history about the Palo Alto Firewall and the developer of the Palo Alto Firewall. Okay. Now regarding this other information, I'll discuss later, like in next class. I don't want to go too much today, just a first class. Okay.